Hi everyone, and thank you very much for joining our session. I'm Francesco Sbaraglia. I'm Site Reliability Engineer and SRE Community Tech Lead. I'm official SRE coach, and I like to write a tech article. I have deep dive and interest in automation, IOPS, industrial software, and cybersecurity. I love kickboxing, indoor climbing, and sharks. Let me give the word to my colleague.
I'm Adriana, a SRE DevOps engineer at Accenture. Originally, I'm from an international relations and security background. So as you can see, I have a great interest in everything what is going around the world, and also specifically for security. I like burritos, and as you can see, I like emojis. So having a quick look at our agenda, we will talk about chaos engineering, specifically for cybersecurity practices. So alongside the purpose and the process section, the talk will include a short demonstration about what we did and how we created some chaos. So let's get started. Why do we need security chaos engineering? And that's mainly because there's a continuous loop of complexity where it's easy to be out of synchronization and lose an overview over the entire system, which is also paired with everyone has its own personal perception and mental models, which is resulting in that we do not have an accurate understanding of what we are securing or what we are configuring because of the constant change and the rising complexity. And that's where security chaos engineering comes into the picture, because we believe in proactive experimentation, building confidence in our own systems capabilities and the ability to withstand. So to make sure that resources and infrastructure remain functional during any condition. So no matter how worse the conditions are, our infrastructure remains functional. So we believe there are several use cases where security chaos engineering would be highly beneficial, including those use cases as security incidents response, solution architecture, and security control validation, just to name a few. However, the way we approach those use cases is much more important, and that's by applying 3 vital practices we can see down here. So that is cyber resilience, security observability, and building confidence in our own system with the purpose to understand how systems behave under certain conditions. Let's have a look at our practices a bit closer. So the first practice is cyber resilience. Cyber resilience is built around the premise that incidents and attacks are bound to happen. So while it would be ideal to prevent them, we need to plan how to respond in an appropriate way. So it's all about anticipation and how well our organization can survive and keep operating no matter how malicious the conditions are. So we can see here that cyber resilience moved away from this static defense approach to a dynamic resilience approach. So the practice offers a framework of 5 pillars. And these are the 5 pillars of resilience. So we have the preparation phase, we have the prevention phase, where it's about that all of the employees need to have a rudimentary knowledge of cybersecurity best practices and know what role they need to play in keep running things and when it finally happens. And it's also about implementation of backup procedures. Then we have the detection pillar and the respondent pillar. And finally, we have the recovery pillar, where it's about leveraging what we have learned. So learning is a really big part here. Let's get to our second practice, the security observability. So we use exactly the same framework as for normal observability. We have different sources where we are getting our data from. We have got the golden triangle, which is telling us that we need to correlate different data sources from logs, metrics, and traces to generate value and to create a certain visibility in our systems to comprehend what we are doing and to comprehend our processes. So what we did, we added the security perspective for observability to figure out security errors, dependencies, and observe if teams recognize attacks or issues. So if there is actually, well, a team member who recognizes what is going on, or if the whole team recognizes that there is something going on. But it's also about implementing policies and procedures and individual security controls. Important here is to measure and observe your security efforts. So to measure if it's effective and efficient. However, looking at the golden signals, which are the most important here, well, they are showing that we can learn a lot during an attack. So we can learn from a system's response, the latency the system it takes a service to request under an attack, or the traffic, which measures how much demand is being placed during a cyber attack. We have got the error rate caught during an attack, and the saturation showing how full the service is while the system responds to a cyber attack. So in the nutshell, we can see here that classical monitoring is not enough, meaning it's not enough to just figure out what is broken, but also we need to know why. And that's why we need observability to continuously learn and improve what is going on. So covering the last practice, we've got a little story from On Call as SRE here. So this guy is sleeping like a baby, not knowing what will happen when the phone rings like hell. As he knows he's on call, he jumps out of the bed, searches for his laptop, and tries to connect to the VPN. He is looking through the runbooks to find what disturbed his sleep. Everyone is counting on him now that the problem will be fixed as soon as possible. He found the right replica, runs the promotion task, and shuts down the old replica. So just a quick reboot, and he made it. Yay! So back to bed. Well, that seemed quite easy, right? So what can go wrong? And that's what we're going to talk about now. So let's talk about what is cybersecurity engineering not. It's not about just fixing an incident and then moving on as usual. It's not a testing platform, nor pen testing or quality testing, and not proving what you already know. It's not a one-time event, it is not a control failure. However, it's about understanding the system's capabilities and the system's behavior and the prevention of rushing in from one incident or one outage into another one. It's about proactively discovering the unknown unknowns, which goes far beyond testing, and it's a continuous activity. So it's a process implemented at any stage with follow-ups based on the previous results. And it's not just randomly experimenting, but it's a controlled experiment. Above all, it's not a simulation, it's a real injection or failure, and has its main focus to learn.
Let's talk about who owns the security chaos experiment. During the planning and execution of a security chaos experiment, we have all the specialized roles actively participating. For example, SRE, production engineer, or security expert. We have as well a functional teams member, like DevOps, DevSecOps, and cloud engineer. Last but not least, SMEs, or domain knowledge experts, with a specific and deep expertise about network, security, cloud, and storage. We can for sure say that the mindset matters. We want to collect any kind of aspect when we are planning and executing the chaos experiment. How do we plan and run a security chaos experiment? There are many ways to run your security chaos experiment. We use the scientific method of continuous cycle of hypothesis and experiment. First of all, we select the target. We get the steady state of the system. We analyze the actual condition, and if needed, do some screenshot of the observability graph and collect deeper information from each component, like version, status, and so on. We create an hypothesis based on what we believe and what we want to prove. We run the experiment. We collect all the information from the system that can tell us what is failed and what went wrong. We analyze the finding and make improvements. And we restart the cycle of hypothesis, experiment, and lesson learned. Let's talk now about the security chaos experimentation. How to use the framework that we saw before. First of all, we have in the preparation phase. We select the target, we prepare the hypothesis, and we reduce the blast radius. We want to target just one proof at the time. Then in the prevention phase, we implement the backup and rollback procedures. Then we have a detection phase. We prepare the tool to observe the environment. So like, for example, the observability tool, we have the logs and so on. Then we run our experimentation. So here we have let the chaos begin. And then at last, we have the recovery phase. Lesson learned and analyze the finding. So for our live demo, we have now selected a specific target, our Kubernetes shadow cluster. In cybersecurity, we usually follow specific phases to evaluate if a system is vulnerable to cyber attacks. Here we can see on the left side a framework from Dimitri. What we selected for our live demo, there are at the end two different security experiments. The first one is about the discovery. The adversary is trying to figure out your network, so the classical network scan. The second one is about initial access. So the adversary is trying to get into your network and steal the data.
So let's talk about what we did. We have a graphic here showing our experiment. We have got a classical web application on top of a Kubernetes cluster. We have got monitoring and logging in place, including Elasticsearch, Kibana, Prometheus, and Grafana. We also have got Argo CD for automation. So most important, we implemented a honeypot as our PIC service for the security chaos experiment. And this one is monitored by the applied monitoring stack, and all incoming requests are logged. So the honeypot itself has artificial intelligence features inside and understands what exactly we are doing. So the chaos experiment will intercept with the honeypot. Francesco will show us this in a demonstration later. And as the attacker, we will create some fake routes going to the honeypot. So what we did based on the common techniques, we created some specific hypotheses, defining what can be expected when a malicious activity or incident disturbed our steady state. And we do some assumptions and say that the incident can either be prevented or detected or neutralized. So for the first security chaos experiment, we formulated a hypothesis as the following. In the event that an attacker gained access to a specific pod within a Kubernetes cluster where he or she is able to map out the network from the inside and scan our services to find a possible open web service, he or she will make a great effort to remain undetected. Under those conditions, we believe that our system and observability tool can detect the scanning activity and alert the SRE team in a timely manner to recognize and block the malicious activity, resulting in that we can neutralize the threat and prevent further damage. So what we have here, we have an attacker who is scanning out our network and services from the inside. And we say we can detect the scanning activity and prevent, well, the attacker for doing further damage. We also have got a second security chaos experiment in place, and this one is about or is for the initial access phase, and therefore we created another hypothesis. And we say, in the case an attacker already gained access to a specific pod, the attacker is trying to remain undetected and inject malicious code into an open service to collect information. We believe that our system and observability tool is collecting the right logs and metrics, which can detect the malicious intent of the SQL injection and alert the SRE team to take countermeasures to the attack. We also have firewall rules and an ingress controller in place, which is supposed to filter the traffic for our web service. Hence, the injection cannot succeed and can be detected by the honeypot. So we've got a SQL injection here, which is committed by an external attacker, and we say the access intent will be detected by our honeypot, which logs all incoming requests. So having our hypothesis, let's get to our demo with Francesco.
Let's move now to our live demo. First of all, what we saw before in our architecture, here we placed the honeypot. Here we can see in the left side how it works with the honeypot. So the honeypot, actually what we wanted to have in the first experiment is that is getting exposed to a specific port. And here we can see the node port. And because we are exporting as a node port, we have at the end one of the worker node that will have this port open. In our case, as we are using like Minikube, here we can figure out which one is the IP address of my worker node. Let's go here and talk about the architecture of the experiment. First of all, we have a specific observability tool that we built to run the experiment. We have Prometheus, where we are collecting metrics from the system. We have a node exporter. Of course, they are getting metrics from each node that we have from Kubernetes. We have Elasticsearch and Kibana, so to also get logs from this honeypot. And then we have Grafana that we will see after that we are getting also a graph about what is happening on the system. Here you can see that we build already some specific graphs that we can monitor our worker node and understand when there are different malicious activities or just port scanning. We deployed already our honeypot, so we can have a look on the system. Our honeypot here is running. Let's check the service configuration. Here we can see that honeypot is exported and is running on a specific port. Now, for the matter of time, I will not scan the whole worker node. At the end, we will find all of this port that is open, but I want to have directly a configuration running. So I will do an enma, and I will specify the port. And then in this case, I need to get the configuration of the IP address from my worker node. I run the scan. Okay, and in fact, I found that there is one port open. So here I'm simulating, someone did a mistake, left a node port configured, and we have bypassed our buff or our ingress. So we can go directly to the worker node and we can go directly to this fake service. What we are seeing on the left side, that actually from the normal monitor, we don't get nothing. So there are no spikes and we don't have any strange activities. But what we build, because of the honeypot, we know from this specific dashboard, directly, those are metrics coming directly from the honeypot, we can get that we had an activity of scanning. So something is strange because this service is fake and they should not receive any kind of traffic. But what we extended, also collecting the metrics coming directly from the log from this honeypot. So actually we track which kind of requests they are getting done. And here we can see that our observability tool already mentioned and already got that actually there is a strange activities, because on this service, it's supposed to don't have any activities in general. First of all, we can get from this graph that we have an activity of scanning. So this is a specific for report scanning. And here on the right side, we collected a kind of an attack index. So if in the last 10 minutes there were some port scanning, I got advised. We built also an heat map. So I can run again another port scanning, and I will see now that it will come also a second activities. So at the end here, we proved that if there is a specific discovery activity, so in this case, a port scanning, on a specific port or targeting directly a worker node, I can see immediately from the graph that we built and from the observability tool that we have the ability to see this malicious port scanning. But now we want to go in the next experiment. It's about the SQL injection. So we prepared a specific SQL injection. So a classical, we downloaded a SQL injector, and we want to test if this application worker node that we exposed is trying to catch the SQL injection activities. In this case, I will run. Let me get the IP address of my worker node. The port that we already opened is already there, 30,007. It's a HTTP port, and let me specify this part. I will run the SQL injection. Oh, we found that we are trying to get a SQL injection on this specific address. It's connected, and the SQL injection worked. If we can see on the left side, it's not counted as a port scanning, but we have a small activities. So our alerting here should check if we have other alert in general. And we can see in the next part that we build a specific part of the honeypot is answering to this SQL injection. If you can see on the left side, we have three activities. So our SQL injection at the end, you can see also the code, is trying to connect to this service, trying to inject and trying to find where it can inject this SQL injection, and then doing it. So in this case, we are answering to the SQL injection. Because it's a fake service, there is nothing behind. I can run again. And I can also run in other ports. And here we see that is not detected. So if I run this SQL injection to another port that actually is not opened, is not even opened, or is opened, is not responding to SQL injection, we don't have the detection. But here, as our specific honeypot is also answering to it, so we put a bit of intelligence inside, we can prove that in our system, if we deploy in automation, we deploy this specific honeypot, we can get and catch if there are, first of all, discovery activities, and second, SQL injection or any kind of other injection.
Thank you, Francesco, for this cool live demonstration. So before we finish, let's sum up and talk about our best practices. First of all, it's always a good idea to be prepared for failure because failure will happen all the time. Start challenging your assumptions, and it's always vital to have a hypothesis in place to verify what you want to prove. It's important when you start your experiments. Don't jump into too fast. Plan your experiment based on a hypothesis, contain the blast radius, and select a target. And make sure that you can always abort anytime in case something goes totally wrong in your experiment. So it's vital to measure everything. As we saw, observability plays an important role here. So it's important to see what actually happened, to learn from your experiment. And what we saw when Francesco was showing the experiment, we did it in a manual way. We had some automation in place, but not for the entire experiment. So the next step would be here, automating everything as well. Automation in SRE and in chaos engineering is very important. So, well, automate everything as much as possible as you see and think, okay, this makes sense. And last point, and the most important, is apply everything you have learned. And that said, we hope you learned something new from this talk and enjoyed as much as we did. And well, thank you very much for your attention. If you have any questions or want to contact us, you can do this via Slack or LinkedIn.